Bismillahirrahmanirrahim. Assalamu alaikum everyone. Welcome back. We are going to resume from the questions that we were doing in lab session 8. As I told you, once you have covered lab session number 8 well, you will qualify to do CEP. So let us resume. We'll be starting off with question number 4 in this video. And the question reads, write a program using a loop that determines the expression square root of 12 summation n equals 0 from n equals 0 till m. You have to calculate all these terms, and the formula for each term is minus 1 upon 3 to the whole power n upon 2n plus 1. And mind you, you are to run the program with m's value as 5, m key value 10, m key value 20, and you are to compare the result with pi. Mind you, the pi value is very much fed in the in our MATLAB already. We know the value of pi. We can calculate it. We have it in our calculator. We have it in with the MATLAB as well. But this is one way, one analytical solution that can help us obtain the value of pi. So we'll be using that approximate analytical solution, and we'll be comparing it with the value of pi, which is actually saved in MATLAB. Now, let us begin. The question reads that you are to use the looping technique. Question can arise that why looping? Why not any other technique? Is there any technique available? Yes, there is. The alternative method is using the formula vectorization, in which you're going to employ the period operator. How? If you notice, the value of n differs. It begins from 0 and it goes all the way to m, right? Where m can be either 5 or 10, so on and so forth. So you know that n varies for each term, and the formula for each term is the same. So you're going to write the formula of each term only once, but you're going to employ n here as a vector, but you're going to use n element wise by using the period operator. So if had this question not read that you have to explicitly use the looping technique, the method would have been that you would have assign n as a vector like this. Wait, let me increase the size. So we would have assigned n as a vector, and then in the formula we would have used, for example, let's calculate the vector t first, in which the formula is minus 1 upon 3 to the power of n, and we would have utilized n as element by element. So in that case, the period operator will be very much important here. Then followed by another period operator for the division, because division and power operations by default are not element wise operations. So this comes here of importance, that we are going to include the period operator here, followed by the denominator within the parenthesis 2n plus 1. Fine. Now this will help us, if we are going to run it, this will help us attain, if you see, there are 6 values of n, so likewise there will be 6 values of the terms, right? Now then thereafter we have to sum all these terms up, because if you notice in the formula there is the summation. So all these terms from n key value 0 till 5, you're going to sum them up, and then you're going to multiply it by square root of 12. So I'm going to go back, I'm going to use square root of 12, and then I'm going to multiply it by the summation. So in this case, I'm going to only get a single result, which is a single result. Sorry, sum of, here we go. So here we go. I'm going to get a single result of t, which is 3.1413, right? And if you compare it with the value of pi, you can notice that it's almost the same, right? If you can use it using format log, you'll see that most of the decimal digits are matching. Anyway, but the question says that you are not to use the period wise or element wise operations. You are to use the looping technique. Now in the looping technique, what will happen? In the looping technique, you will be calculating each term one by one in each pass. You'll be saving those, and then you'll be summing them up one by one. So when you do not have any term, the sum is 0. But when you will get the first term, the sum will be equal to the first term. When you get the second term, the sum will be equal to the first term. and the second term, right? So on and so forth. In a similar way that we have practiced in the class. So anyway, what I'm going to do is I'm going to erase this all, and also I'm going to make sure to switch to format compact, and I'm going to clear the previous results. Anyway, so what I'm going to do is, in my case, I'm going to enclose for in not as a vector, but I'm going to keep them as in within for. So here n will be one by one by default. First, in the first pass, n key value will be 0, in the second pass 1, in the third pass 2, in the fourth pass 3, so on and so forth, right? For every for, there has to be a corresponding end to make sure you end immediately before you forget. Now, I have to calculate each term, and the formula of each term was minus 1 upon 3, sorry, to the power of n upon 2n, 2 times n plus 1. Now, mind you, here I'm not going to include any kind of period operator here. Why? Because by default, whenever you are enclosing this vector, this loop index variable n within the for loop, the n will be treated by default element wise. So in the first pass, the value of n will be only 0. In the second pass, n key value will be only 1, so on and so forth. Now, moving on. In most of the scenarios, in most of the cases, you'll find, not in this question, I'm talking about generally, most of the questions you're involving in loop, they will restrict you not to use the function sum, right? In this case, it's not written, so let's assume for now that it is written that you're not supposed to use the function sum. Otherwise, you would have saved term in the form of a vector, which I'll show you how, and then you will be utilizing the similar method that you did in the previous method. For now, assuming that the question has explicitly said, let's say that do not use a function sum, what I'm doing is, before any terms have been evaluated, I have assigned a variable s and I've assigned a value of 0 to it. In the first pass, when the first term will be assigned, I'll redefine the sum, the variable s, as s plus t. Now, in the first pass, the value of s has already 0 saved. So in t, the first term has been saved. So s in the first pass will be the first term only. In the second pass, when n key value is 1, second term will be evaluated, and in s only the first term is saved. In this t, the variable, the second term is saved. So in the second pass, s plus t will give you the summation of first two terms. That's all about it. I'm going to put a suppressor at these two statements, line 3 and line 4. I'm going to come out of it. I'm going to come out of the for loop, and then let's say e variable. I'm going to then multiply square root of 12 to a single sum variable, which is s. And if I'm going to run it, you will see a single result, 3.1413, which is pretty much similar to the one that we got before. If you want, you can use format long as advised by the question, and you can check the value with pi. Let's see, compare it with the value of pi. Let's see the result. So this is e, and this is the value of pi, which is in the fourth, fifth decimal digit. You see there are a little bit of variations, fine. But up to, let's say, the first 3 decimal digits, they are more or less the same. If the question had been that you were not allowed, for example, you are allowed to use the function sum, in that case you would have saved, you can save t as a vector. And how is that possible is, you would have saved the t in the vector form by using the array addressing techniques, and in that case you would have kept n outside the loop, and you would have used, for example, k numpy index variable, and you have run it for, let's say, length of n, fine, and you would have used this k and for as an element address. So t will not just be t will be in fact t of k, and n will not just be n, it will be n of k, so on and so forth. That's it.